Okay, so in this video we're going to review a practice practical for iGCSE physics, and this one we've got reflection, and we're also going to look at resistance as well. So the first one, we're going to be using an optics tray to essentially illustrate reflection in the images we get. Now we've got some instructions here about what we're going to do in terms of constructing it. So we're going to jump straight in and draw what this looks like. And so these are all the stages that we're going to go through. So if you need to, pause it and take a look what those are. So having followed all the instructions, what you get is a board that looks like this. And essentially what we've got in here is we've been asked to measure the two angles of reflection, and I got them as 30 degrees and 50 degrees. There's a small tolerance either side in terms of your measurements. So this is the diagram we end up with, and we use optics pins to mark the path of these rays. Okay, so we can now fill it in. So the first angle of reflection we saw was 30 degrees. The second one was 50 degrees. And as I said, you had a 2-degree either way tolerance in terms of getting these correct. And that was actually penalized on this second question here. So the second mark was for being within 2 of 30 and 50. State whether it's best to view the tops, bases or central parts of the pins in order to obtain accurate results, giving a reason. So we want to look at the base of the pins because we can't be sure we've actually stuck in the pins vertically or perpendicular to the tray, but if we look at the base, it doesn't actually matter too much. Okay, so that's the optics tray part of the tool. Let's move on to have a look at the electricity part, and I've got some examples to show you where you're getting marks on this. So what we're doing is we're changing the length of a wire that we've got a voltmeter connected over, and we're seeing the effect of the length on the voltmeter reading. Okay, so that's what we're going to do, and we're going to go do it in 10 centimeter intervals, actually 10, 30, 50, 20 centimeter intervals. Okay, so here is a table of data that would get all of the marks on this one. So in the top column, we've got all of the units that we're measuring in. All of the voltmeter readings are to 2 decimal places because that's what the voltmeter that was used can do. All the ammeter readings again were 2 decimal places, and the ammeter should have stayed roughly the same the whole time. And we've got all our resistance values to 2 or 3 significant figures because that's the data we are using. Okay, so that's our table of data, and then we've got a graph, and again what we're looking for our axes labeled correctly, that we've got sensible scales chosen on both the x and the y axis. So I think a sensible one here is 0.5 volts on the y axis and 1 ohm intervals on the x. And we're looking for a line of best fit that has roughly equal numbers of points above and below it. That's what we're looking for. So something I would pick up at this stage is we're going to measure the gradient later on, and I really like what I'm seeing here, that I can see clearly the triangle that's used to calculate the gradient, but what I'm not happy about is this amount of the graph used to do that calculation. That's actually going to cost a mark. So a gradient triangle should cover over 50% of the line, so we should be using a large amount of our best fit line to work out a gradient, so that's going to cost a mark. In terms of the actual way the calculation is done, that's absolutely fine, but gradient has units. We're going to do change in y over change in x, so it should be volts per ohm is the unit that we'd give for the gradient. And that completes this review of the practice practicals.